Good evening, everybody, and once again, welcome back to the channel. A few days back, I wrote this blog syncing all the three table formats such as Hudi, Delta, and Iceberg with Apache XTable running on AWS Lambda function. In this, in this architecture, of course, the Apache XTable sync command is running on a Lambda function. Lambda function being serverless can easily scale up and down, and it's also quite cheap and cost effective, right? So the way this works is it takes the path to the config file. The config file resides on S3. The Lambda function downloads it locally in the temp directory and executes the sync command. So I remember I said I'll write the infrastructure code over the weekends and then I'll update you. I have done that and I just want to show you that particular process. So the infrastructure code is quite simple. I define a service, right? Provider as AWS, architecture is ARM64, the runtime is going to be 3.8, memory is going to be 3 gigabytes, timeout is set to 500, and then here is my IAM permission. I'm giving access to S3, and then here is my Lambda function. Now to deploy the stack, all you gotta do is just say two words, SLS deploy, and this will deploy the stack on AWS. I have already actually deployed it, so I want to show you that. So if I can show you here function, here you can see XTable sync dev XTable, right? Then now I can of course test and show you. So first you will write your config.yml file, right, which points to the Hudi table on S3 where it is, right? So if I go to S3 here, this is where my Hudi table is, right? Inside data lake demo 1995, inside the folder Hudi, right? I define that. I wanna build the metadata for Iceberg. Once I define my config.yml file, now push your config.yml file to S3. So here I'm using the command AWS S3 CP. This is the path to the config file locally, and this is where I want to ship it on my S3. Easy, I'm gonna do that. So the config has been uploaded, and now I can fire up the Lambda function. So now if I go to Lambda, let's see if it actually works, right? Because last time when I showed you, I ran it locally, right? I ran the Lambda function locally on Docker containers, and now I'm actually gonna run it on AWS Lambda. So let's refresh. All right, so I'm gonna go to the test section, and then I'm gonna put the payload. Here you can see path, and this is the path where the config is, right? It's on S3. So the Lambda function should download it, right? So if I click on test, you can see the Lambda function is executing and the execution is successful. Now if I go to S3 and I simply refresh, look at that metadata, and here you can see Iceberg related metadata. So coming back to the architecture, yes, the Lambda function works flawlessly. It builds the metadata for all the three table formats. You can schedule this via EventBridge if you want, right? On a daily, hourly, however you like, or you can hook up an API gateway and invoke it by a REST API. You can also do that through a process driven, right? For example, let's say your Glue job or Spark job is complete. You can just fire up this API call and it will do the metadata, right? So in this video, what I just wanted to show you is the solution is now deployed on AWS. I have tested it for Iceberg, so it works. And I've also updated the infrastructure code. So now you can deploy the solution with one command, which is serverless deploy, and it will create a repo in ECR. It will push the Docker image. It will create the Lambda function, and then all you gotta do to use it or for the clients, upload the config on S3 and pass the payload to the Lambda function, and it will download it, execute the sync command, and it does everything for you. So that's all I have for the video. I hope you guys have enjoyed the video. If you have any other questions, let me know. And also I'll leave the blog links in the description. So in case if you want to try the solution out, feel free to try it out, okay? With that being said, keep smiling, keep programming, and I'll see you next time.